Okay, so let's understand the slope of a line. An easy way to put this is the slope of a line is the rise over the run. And so it's how far you go up and down over how far you go left and right. So really what you would be looking for is the slope of that line right there. How far you go up and down over or divided by how far you go left and right. So the rise measures the vertical change, the run measures the horizontal change. Let me explain just a little bit. Okay, so in this example we're using a geoboard, and a geoboard is just a board with a bunch of pegs, and this thing right here that you're looking at, that is a rubber band. And since I can't really show that to you exactly, I've got a picture of one, okay? And so what we're trying to find here is we're trying to find the slope of this line right here in between these two pegs. So how steep is that line? And so you have to count how far you have to go up. So I always start at my lowest point and I count how far I have to go up to get to this point up here. So I'm going from this point down here at the bottom to this point up here at the top, and I'm going to count how far I have to go up. You go straight up. Everything is in vertical, and then true horizontals. So I can't count diagonally. So I go up 1, 2, 3. So my top number is 3. And then from this dot right here, I'm going to count how far I have to go to the right. To the right, I have to go 1, 2, 3, 4. So the slope of this line is 3/4. Okay, so now we're going to count from this peg right here to this peg right here. And remember, you can't count diagonally. You have to count vertically and then horizontally. Okay, so starting at this lowest dot, I have to go up 1. So my numerator is 1. Now, check this out. From this dot right here, I have to go to the left. If you're looking at a number line, going to the left is negative. So I have to go to the left. 1, 2, 3. And because that's left, I count that as -3. Okay, so the slope of this line right here is -1/3. And it doesn't matter where that negative is. As long as you only have one negative sign, it doesn't matter where it is. So let me erase this and let's go the other direction. So if I started at my top peg right here, I would go down 1. Notice going down on any sort of number line is negative, so that would be a -1. Then I have to go to the right. Right is positive 3. So you still get -1/3 no matter which direction you start at. Okay, so we won't always be given geoboards. And so now we have to find the slope of the line, and we're not given the pegs anymore, and we're not shown where the good dots even are. So you want to pick dots that lie on the line that have integer coordinates. By integers, I mean whole numbers, positive or negative, it doesn't matter, but they need to have whole number coordinates. So I'm going to choose this dot right here that lies on this line. Now, I wouldn't choose this dot right here because that's not an integer. So I am going to choose this one way up here. Okay? I usually start at my lowest point. So I always go up, and anytime you go up, that's positive. So going up 1, 2, 3, 4. Numerator is 4. Then I go to the right 1, 2, 3, 4, 5. Denominator is 5. So my slope of this line right here is 4/5. Okay, so let's look at this one and let's find two good dots that lie on this line. So this right here looks like a good dot. Looks like it has integer coefficients. It has integer coordinates. This coordinate right here would be what, 3, 3? Okay, and then let's look for another one. This one maybe? This one looks like it has 6, 1. Those are whole numbers. So now I'm going to count from the lowest dot, this one right here, the 6, 1 dot. And I have to go up 1, 2. Up is positive, so I go up 2. And then I go to the left 1, 2, 3. So left is negative. Now, I want to show you something else. What if I had chosen different dots that were further away from each other? So what if I had chosen this dot right here and maybe this dot up here? Because maybe I didn't notice the one that's in between. So let's count. 1, 2, 3, 4. I go up 4, and then I go to the left. 1, 2, 3, 4, 5, 6. Left is negative. Now, you always reduce your fractions, even with slope, so this would reduce to be negative 2/3. So even if you pick dots that are further away from each other, as long as they lie on the line, if you pick them further away from each other, you'll still get the same slope, you just have to reduce at the end. And that's okay. Okay, so let's find the slope of this line. So I'm going to put a dot right here, and another one with integer coordinates is right here. So I'm going to count up 1, 2, 3, up 3, then I'm going to go to the right, 1, 2, 3, 4, 5. So the slope of this line is 3/5. Okay, this might be a page that you want to pause and take some notes on. All horizontal lines, remember horizontal lines look like this. They only have a y. B is a number. Okay, this is a number right here. So they only have a y in the equation. So this could be y equals 1 or something like that. B is a number. It only has a y as the variable in the problem. All vertical lines only have an x. A in this case is a number. By the way, they're letting you know here that the slope of all horizontal lines, think of the floor. The floor that you're standing on right now probably has a slope of 0. I'm willing to bet it does. So then the slope of all vertical lines look like this. That's like the walls in your house. Those have slopes that are called undefined. Okay, so find the slope of each line. So x equals 8. Now, in this problem right here, x equals 8, I'm going to graph it on this one. I'm going to find where x, remember this is my x-axis, this is my y-axis. I'm going to look at where x is 8, and it's 8 at, here's 2, here's 4, here's 6. It's going to be on the edge of this graph. Now, what I want you to remember with this, because we only have an x in the equation, that means that it can only cross the x-axis. So it's going to be a vertical line at x equals 8. Notice how it does not cross the y-axis at all. It's not allowed to have a y in the equation if it doesn't cross the y-axis. So what is the slope? Remember, we're finding the slope. What's the slope of a vertical line? All vertical lines have the same slope, and it is undefined. Okay, so now this next one, the y equals -5. We're going to graph it right here on this graph. So I'm going to go down to where, remember this is my x-axis, this is my y-axis. I'm going to go down to where y is -5. Here's -2, here's -4, here's -6. So -5 is in between there. And because it only has a y in the equation, it can only cross the y-axis. Remember, this is like the slope of your floor. So the slope of this is 0. This would be a great page for you to stop and take notes on. And I used to do this picture right here. It's kind of a silly picture, but I'm hoping it helps you remember. So I've got a little car here. And this car only travels to the right. And so whenever this car is just sitting here, he is actually not moving. So his slope is nothing. He's not doing anything at all. But as the car travels up this hill, his slope, he's having to step on the gas. So he's giving it a lot of gas. That is a positive slope. As the car travels down that hill, he's having to actually do the opposite of giving the gas. He's giving it the brake. So that's a negative slope. And then the guy reaches this cliff and he falls off the cliff and he becomes undefined. Again, this is a great place for you to stop and take some notes. I want you to realize that we use the letter M. M means slope. Okay? So whenever we're talking about M, I'm talking about slope. And I want you to understand that these little numbers right here and here and here and here, those are subscripts. Subscripts are used to name something. That doesn't mean multiply by 1. That doesn't mean multiply by 2. It's used to name something. So this slope right here means I'm going to take the y that's in my second point and I'm going to subtract the y in my first point. And I'm going to divide that by the difference between the x in my second point minus the x in my first point. I want you to realize here that notice how those line up. Okay, that's really, really important. Do not write these out of order. Okay, so if I'm going to find the slope between these 2 points, I'm going to name these x sub 1, y sub 1, and x sub 2, y sub 2. And I'm going to use the slope formula. M is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, sometimes it's easier for people, especially once we start dealing with negative numbers, if you do this. And then fill in your blanks for your parentheses. So what goes here? Y sub 2 goes in that first position, and that is 5. So I'm going to put that right there. Now, what goes right here? That's y sub 1, and that's this number right here. And now this is my x sub 2 position, and that's this number. And my x sub 1 position goes right here, and that's this number right here. Now I'm just going to do the math. So 5 minus 2 is 3. 4 minus 1 is 3. And you always reduce. So 3 divided by 3 is 1. So my slope of this line is 1. Okay, this is one of those cases where it's actually going to be easier if you do the parentheses. So remember, we're going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to fill in my parentheses here. And I'm going to name this x sub 1 y sub 1 and x sub 2 y sub 2. So y sub 2 goes right here. So that's a 4. Y sub 1 goes right here, and that's a negative 3. X sub 2 is negative 7. And x sub 1 is negative 2. So this problem now becomes, notice you have a double negative, 4 minus negative 3. So those cancel each other out, and I get 7. And now look, I've got another double negative down here, and so that is negative 7 plus 2, which is negative 5. So this can also be written as negative 7/5. Okay, so I'm going to graph the line that passes through the point 1, negative 1, whose slope is 3/4. Remember, this is our rise over our run. Okay? The very first thing that you have to do is you have to graph this point right here. So I'm going to go to 1, negative 1, and I'm going to put a dot. And I'm assuming that all of these labels we're just counting by 1. So I'm going to label every other one. 2, 4, 6. Here's negative 2, negative 4, negative 6, negative 2, negative 4, negative 6. Okay, So now I've labeled my graph, and I'm going to go to 1, -1, and put a dot. So that's right there. From there, from this dot, I'm going to graph my rise over my run. My rise says I go up 3. That's a +3, so I go up 3. 1, 2, 3. Those are little mini dots. Those aren't real dots. And then that's a +4, so I'm going to go to the right 4. 1, 2, 3, 4. And this is a real dot right here. Okay. Now the next thing you need to do is you always need to connect your dots and draw arrows on the end, because that line does go on and on forever as far as we know. So this right here is the graph that passes through this point with this slope. Okay, on this problem right here, I'm going to graph the line. Now y-intercept means that's where it crosses the y-axis. The y-intercept also has an ordered pair of 0, 2. So I go left or right 0, and I go up 2, and I put a dot. From there, I'm going to do my slope. Now remember this negative sign right here. That means that that negative is either assigned to the top or it's assigned to the bottom, but it is not assigned to both. So what this could mean is I could go down 2, right 3. So down 2, right 3. Or, according to this one right here, I could go up 2, left 3. Look at how those dots line up in a straight line. So, connect your dots, draw your arrows, you are done. Okay, so in this problem, I'm going to graph the point -1, -3 first. So -1, -1, 2, 3. So I have a dot right here. Now, check out this slope. That's not written in fraction, but can we turn any whole number into a fraction? We sure can, by placing it over 1. So that means I can go up 4 from this dot, right 1. 1, 2, 3, 4, right 1. And you can keep doing that if you want. Put another dot on there. One thing I do want you to realize is +4 over +1 is the same thing as -4 over -1, because what is a negative divided by a negative? It's a positive. So what this means is I could go down 4, left 1, and I still get a positive slope. Down 1, 2, 3, 4, 1. Check that out. So I'm going to use a straight edge here. My straight edge is moving, sorry. Ooh, it doesn't like the straight edge on here, so there we go. Sorry, I know I missed some dots there. It's really hard to do when they're far away. Nonetheless, that slope is steep, but it is a positive slope. Okay, so the pitch of a building's roof happens to also be the slope of the roof. Knowing the pitch is important in climates where there is heavy snowfall. If the roof is too flat, the weight of the snow may cause it to collapse. What is the slope of the roof shown? Okay, so remember, rise over run. So if I'm looking at how steep this line is right here, maybe it'd be better if I used a different color, this line is, then I want to do the rise divided by the run. So the rise in this case from here to here is 9 feet, and the run is 18. Always reduce if you can. So my slope is 1/2. Okay, so on this one it says sewage pipes must slope down 1/4 inch per foot in order to drain properly. What is the required slope? So what I want you to realize here is we're dealing with inches and we're dealing with feet. So it's easier if you're actually working in the same units. So 1 foot is equal to 12 inches. So remember, rise over run. Okay? But I want you to realize this is our pipe right here. That pipe is sloping downwards. So really, we need to realize that if we're going downwards, that our slope is going to be negative. So make sure that your answer at the end is negative. So I've got negative 1/4 divided by 12. This is the same thing as negative 1/4 divided by 12 over 1. Remember, keep, change, flip on our fractions. Negative 1/4 times 1/12. And whenever you multiply straight across, you get negative 1/48. So our slope is negative 1/48.